All right, so y'all, this is number 7 out of 6.3, and it says a researcher wishes to estimate with 90% confidence. Okay, so first thing I'm going to do, I know my confidence interval is 90%, the population proportion of adults who think Congress is doing a good or excellent job. Her estimate must be accurate within 2% of the true proportion. Okay, so there's 3 parts to this problem. Part A says no preliminary estimate is available. Find the minimum sample size needed. So what I did, y'all, I went through my notes from 6.3 and I took a screenshot right here. So this is the formula that I'm going to use to find my minimum sample size. So it says the minimum sample size N needed to estimate the population proportion P is, and it gives me this formula right here, okay? And it says, assuming that you have point estimates P hat and Q hat, otherwise we're going to use P hat is 0.5 and Q hat is 0.5 to ensure the largest sample size. Okay, so what I'm going to do is I'm going to write down my formula. N equals, let's see, P hat Q hat times, I think it was ZC over the error. And all of this here is being squared. Okay, so Part A says no preliminary estimate is available. So in Part A, since no preliminary estimate is available, P hat and Q hat are going to be the same at 0.5. So right here, I'm going to type in 0.5 times 0.5. Now, I need to find my ZC, right? So let me show you again how I'm going to do this. So I'm looking for that Z-score. Let me get my normal curve going on here, okay? So I'm looking for my Z-score so that 90% of the area is here in the middle. So remember, we have 2 values. One of them is negative, one of them is positive. I can find this value, and then once I find it, since it's negative, I'm just going to make it positive so I can use that one right there, because that's really the value I'm trying to find. So remember, the whole area, y'all, is 100%. We're going to subtract off, 90%. That's going to give me 10% as a decimal. That's 0.10. But that needs to be divided amongst these 2 areas. So the area over here is 0.05, and the area over here is 0.05. So remember, if I want to do this on my calculator, the way I can do this is I can go inverse norm, okay, of 0.05. So let me do this part of my calculator real quick. Let me get this guy going, clear it all out. Second vars, we're going to go to inverse norm, 0.05. There we go, hit enter. Okay, so I'm coming up with a negative 1.64. So right here, this number is negative 1.64. This one obviously is going to be positive 1.64, right? Okay, so let me come back over here. 1.64. Our error is 2%. So if the error, y'all, is 2% as a decimal, that's 0.02. So 0.02, and this part here is being squared. So I'm going to enter this piece in here on my calculator, okay? So let me grab my calculator again. Let's clear all this out. 0.5 times 0.5 times parentheses 1.64 divided by 0.02, and that needs to be squared, and I'm coming up with 1681. Okay, so the answer for part A is 1681, and that's coming out nice and pretty. So let's double check our answer. It's going to come right here. There we go, 1681, and check it. And we got the first part, okay? Now let's do part B. So let me take a screenshot of this, okay? Back over here. And let's upload that picture right here. Okay, so formula is still the same, y'all. My formula N is going to be P hat Q hat times my ZC score over the error, and this is being squared. Now the only thing is different now is that my P hat, y'all, is 38%, which as a decimal is 0.38. So remember, my Q hat is 1 minus 0.38, which should be something like a 0.62. So when I do this one here, I'm going to type in 0.38 times 0.62. And then the z-score we already found to be 1.64 divided by 0.02. This is all squared. So the only thing that I really did here, I just changed those values, right? The rest of it stays the same. So look, I'm going to come back to my calculator. Instead of me having to type in everything all over again, well, it's okay. Let's do it. 0.38 times 0.60, oops, 62, come on, 2, there you go. And let's see, 1.64 divided by 0.02, and that's being squared. And I'm coming up with 1584.17. So right here, I'm coming up with 1584.17. Now, I want you to notice something here, y'all. Round up. So even if I end up with 1584, I'm going to round this up to 1585 because I'm rounding up no matter what kind of change I have, like whether it's 0.17 or 0.97, I'm going to round it up, okay? So look, we're going to come back over here, and we came up with 1585, okay? And we got it, okay? And there should be a part C. Okay, how do the results compare from A to B? Having an estimate population proportion raises the minimum size. So look, part B, we had a population proportion. Did it raise it? Did it go up? No, it didn't. So I know A is not a good choice. Having an estimate for the population proportion has no effect. No, those numbers are different. And having an estimate population reduces. Yes, that number from 1681 went down to 1585. So my choice C, we check it, and we got it, okay? So this is number 7 from 6.3.